This is Lesson 11, Chapter 3, Section 1, Lines and Angles. The objectives of this lesson are to identify parallel, perpendicular, and skew lines, and to identify the angles formed by two lines and a transversal. Your vocabulary list includes parallel lines, perpendicular lines, skew lines, parallel planes, transversal, corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. If we look at the graphic on the right, we see a cube with all of the lines labeled. You can see special notation on some of the lines. Over here on EG and FH, we have two little red arrows. These denote that these two lines are parallel to each other, just like EF and AB have those same marks. Parallel lines, and we use the notation of two little lines straight up and down. Parallel lines are coplanar and do not intersect. If you extend them forever and ever, they will never cross. In the figure, just as we said with the red markings, line AB is parallel to line EF, and line EG is parallel to line FH. Perpendicular lines, and we denote those with an upside down T, intersect at 90-degree angles. In this figure, you see the little red corners that show you the 90-degree angles. Line AB and line AE intersect as perpendicular lines. And line EG is perpendicular to GH. Skew lines are not coplanar. They're also not parallel. They don't intersect anywhere. They just keep going on and on and on in both directions, but never touch and aren't in the same plane. In this figure, line AB and line EG are skew. Parallel planes are planes that do not intersect. Plane ABE is parallel to CDG. Segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. So since they're included in the line, whatever's happening with the line is also happening with a ray or a segment. Let's look at an example. Identify each of the following: a pair of parallel segments. Well, let's look at segments that are parallel. And I see NS and MR. I can also see that those are both parallel to, let's see, KP and LQ. And then I have the ones on top, I have LM and I also have KN. LM and QR are parallel segments. LM, QR. A pair of skew segments would be KN and PQ. PQ keeps going this way. KN is above it and going in a different direction. A pair of perpendicular segments, we can look at NS right here and SP. There's a 90-degree angle there. Parallel planes. Well, let's look at NMR, and KLQ, the one in the back and the one in the front. Now you try. Use the drawing and identify a pair of each of the following. You might have said that a pair of parallel segments were BF and EJ, although there are certainly more. A pair of skew segments might be BF and DE. A pair of perpendicular segments, you might have said BF and FJ, where we have the right angle mark made. And a pair of parallel planes, you might have chosen FJH and BCD. We have more definitions. We're going to talk about angles that are formed by a transversal. A transversal is a line that intersects two coplanar lines at two different points. The transversal T in this picture and the two lines R and S form 8 angles, and they are numbered for you. Corresponding angles are sometimes hard to understand, so let's think about it as being in the same position. They lie on the same side of the transversal T and on the same sides of R and S. For example, 1 and 5. We can see that our two lines, R and S, 5 and 1 are both on top, and they're both on the left side of T. Other corresponding angles would be 2 and 6, 4 and 8, and 3 and 7. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal between the two lines. So I could have 3 and 6 and 4 and 5. Those would be the interior. Think about they are inside the two lines. Alternate exterior angles would lie on opposite sides of the transversal and on the outside of the two lines, the exterior. For example, 1 and 8 and 2 and 7 are alternate exterior angles. Same side interior is pretty easy just by its name. They're consecutive interior angles. They're on the same side of the transversal, just like the name says. So angles 3 and 5 are same side interior angles, as are 4 and 6. Let's try another figure. An example of corresponding angles would be 1 and 5. Alternate interior angles, well, we could have 3 and 5. But 4 and 6 would work as well. Alternate exterior angles, we could use 1 and 7 or 2 and 8. For same side interior angles, we can have 3 and 6 or 4 and 5. Now you try. Give an example of each angle pair. You might have chosen angles 1 and 3 for the corresponding angles. You could have used 2 and 4, 5 and 7, or 6 and 8 and been correct. For alternate interior angles, you can use 2 and 7 or 3 and 6. For alternate exterior angles, you might have chosen 1 and 8 or 4 and 5. For same-side interior angles, you might have chosen 2 and 3 or 6 and 7. To determine which line is the transversal for a given angle pair, look for the line that connects all the vertices. Let's look at another example. If we want to identify angle pairs and transversals, let's look at 1 and 3. 1 and 3, the vertices are both along the line L. Our transversal would be line L. They're both on the same side of L, and they're on the left side of lines M and N. So they would be corresponding angles. The transversal is L, and they are corresponding angles. Let's look at 2 and 6. Their vertices are across line N. So our N would be the transversal. They're on opposite sides, but they're both inside the other lines. So these would be alternate interior angles, and the transversal is N. If we look at 4 and 6, their vertices are along line M. They're on the outside of lines N and L, so they must be alternate exterior angles, and the transversal is M. Identify the transversal and classify the angle pair for angles 2 and 5 in this diagram. Did you say the transversal was N and they are same side interior angles? If so, you are right. Let's try a little bit more practice. If we want to identify a pair of parallel lines, I can only see 2 lines that are parallel. And those would be lines G and H. A pair of skew lines H and J are skew. What about perpendicular lines? Well, there are only 2 lines that intersect, and we are given this nice 90-degree angle sign here. So that would be line J is perpendicular to line G. In the next figure, we have a triangular prism. And we want to find a segment that is parallel to segment DG. Well, we have 2 choices. It could be JF or FJ and EH. For number 5, we want a segment that's perpendicular to GH. It would be HJ or EH. A segment that is skewed to JF would be DE or GH. One pair of parallel planes. We could look at plane DEF, the front part of the prism, and GHGJ, the back part of the prism. One pair of perpendicular segments, not including GH, would be segment DE and EH, or DE and EF. One pair of skew segments that doesn't include JF. We could use DG and EF. Let's look for some more corresponding angles. For number 10, we have a lot of them, but you could have used 1 and 3, 2 and 4, 5 and 7, or 6 and 8. For alternate exterior angles, we can use 4 and 5, or 1 and 8. Same side interior angles would be angles 2 and 3, or 6 and 7. Alternate interior angles, again, would be angle 3 and 6, or angles 2 and 7. Let's look at this triangular figure that we have. And we want to identify the transversal and classify each angle pair. Why don't you give it a try? For 1 and 2, it's N and same side interior. For 2 and 4, you should have put down M and alternate exterior. And for angles 3 and 4, P and corresponding angles. For the next class, be sure to bring your notes. There will be an open note quiz, and I'll see you soon.